This is the story of 3 young engineers and a business major who are on a quest to win the Fall 2016 ME 2110 competition with all their hearts. My name is Will Clayton, and my team members consist of Omar Alam, William Curris-Clare, and Jack Gorman.
The overview for our project includes an introduction, motivation, which includes problems, customer needs, challenges, which is including engineering requirements and functions, and designs, what we've planned and what we've learned, and then finally a conclusion. To sum up everything we've learned in the class, ME 2110 is holding a final project which includes competing against other students. The theme for this competition is Monty Python and the Holy Grail.
The primary motivation of this project is to win the competition. Along with this comes receiving a satisfactory grade and fine-tuning our engineering skills that will help us in later jobs and classes.
The customers for this project are the team itself. The team takes pride in what we do, and we want to make sure that we can succeed. Since we are also solely benefiting from this project, we want to have the most success we can. Also as instructors, as they want to see us succeed and that everything we have learned goes effectively.
The problem: removing the Black Knight from our zone, collecting as many shrubs into our zone, throwing as many holy hand grenades into the Beast Slayer, and ultimately obtaining the Holy Grail. To approach these challenges, we use several different methods. The House of Quality helped us map out what our needs and prioritizations were for our final project. Some examples included dimensions and speed. The next approach we used was the function tree. The function tree allowed us to split it up into several different subsystems, and from each subsystem branch out to make our machine run as efficiently as possible. The last approach we used was the specifications. The specifications allowed us to know how we were going to achieve our end goal. The specifications list needs to be updated constantly, and that our designs are always changing, and not all of our designs are up to competition standards. There were several approaches when it came to the strategy of our project. The first was planning. We implemented a Gantt chart, planning tree, job responsibility chart, and evaluation matrix. This not only divided up jobs between the group members, but allowed for prioritization between different tasks. With the planning out of the way, it was easy to go and implement our design. Our main strategy was to start simple, and then from that simple design, build off into a more complex design. From there, we were to ask questions and test often. I want to apologize for my improper safety practices. As of right now, this is our shrubbery design. We started out with a simple base, arms, and a hinge system. From there, we moved on to sweepers, installing a Myrio, and solenoid and motor controls.
We have faced many challenges across this path. One of the most common problems we've had is not having the proper materials. Sometimes we have not the right screw, the wood, or just any other object. As you can see in the top right corner, we were trying to make our string revolve around our motor. Unfortunately, we lacked the proper part, so we had to go with tape. It's not as effective, but it still works. Hopefully later in the competition, we will have a better working part. Also, we've had a lot of mousetrap failures. Mousetraps have come unreliable to us, and they haven't worked really that well. One of the biggest problems with mousetraps is triggering. Also, we've had many problems with actions not going according to plan. We've drawn up or designed many different ideas, but when we put them into action and test them, they don't always work. However, with many challenges, we've come up with solutions. One of the solutions we came up with, one of our problems, was this block of wood. As it might not seem that complex, it actually does a lot. The block of wood blocks the arm from going backwards when it's getting torqued. However, we know our designs are also not perfect. We have to come up with many alternative designs to always constantly be improving. One of the biggest problems with us is our solenoid trigger. The solenoid trigger has been kind of hard to deal with and is kind of slow. However, the pneumatics kit will allow a quicker release and a much easier. We will have to adjust our designs, however, it will improve our performance. As Dr. Kerfus would say, fail early and fail often. With each different task we are given, we should make sure we're testing. We are bound to make mistakes. However, we will correct them. As we go forward with this project, we have to make sure that everything is operating first. We don't want to disqualify ourselves or have any other problems that will set us back. However, we know that just having a functional machine is not going to help us. We need to beat the competition. In order to reach our goal, we need to have the best possible machine, and that is making constant improvements. Also, we also need to make sure that our parts are very simple. We'll soon have to combine all of our things into a very limited space, and some of our designs might have to take some trade-offs. As we saw earlier in the video, there are 22 days into the competition. Our team will keep on improving and working hard until we get that first place trophy.